my name is Jason Overby. Thanks a lot for coming out. I recently worked with a remote team of a couple other people to build a serverless framework called BAM. And BAM is a framework. You can use it to quickly deploy applications integrated with serverless technologies. It's built in JavaScript and supports Lambdas written in Node. So before I talk about BAM, I'm going to talk a little bit about serverless, though. So serverless is kind of a buzzword. The last couple days, there's been something on Software Engineering Daily about serverless. It's kind of like a thing that people are talking about. But of course, it's a little bit of a misnomer because there are servers. You're just not dealing with like an addressable server. You're dealing with something that exists somewhere, and you don't necessarily have control over it. So it allows you to focus more on the business logic as the developer, but you just don't have control over the infrastructure. And in addition to serverless, there are a variety of options. If you wanted to, you could have your own physical server, which is like a Dell server, bare metal. With that, you have the most amount of control because if you need to scale up, you can add more hardware. You can control the software, but it's not really abstracting away anything for you. So, as you move down through the table, you're giving up a little bit of control, but then it's taking something away that you don't have to manage. With something like infrastructure as a service, you don't have to manage the physical hardware, but you still have to manage all the software in the operating system. And then with a Docker container, you're not managing the operating system. And then you move down to something like Heroku, which is platform as a service. And with that, you're kind of just managing your code. And then finally, serverless, which here I'm talking about it as FAS and BAS, functions as a service and backend as a service, represented by AWS Lambda and API Gateway. There is no infrastructure because it's kind of broken apart into separate parts, and you're handling them separately. So functions as a service, and again, this would be something like AWS Lambda. Like small bits of code that operate in ephemeral containers that are spun up on an as-needed basis. They're good for scaling. Like you can go from 0 to infinity, essentially, without having to manage anything, because it's managed by whatever company is a serverless provider. Backend as a service are components that are related to the back end of the operation. Like there's auth is an example. Like authorization might be something that you'd use it for. Storage, Amazon S3. It could even be like individual FAS components. And so because everything is modular, or because like FAS components are modular, it allows you to iterate rapidly, to experiment, and this leads to like a quicker development cycle. And again, you don't have to worry about scalability because Amazon or whatever company is going to take care of that for you. So Amazon, as I mentioned, is one of the providers, and then there are others. There's Microsoft, Google, IBM. A lot of people are getting into it now. And BAM uses AWS. I mean, AWS has been around for a long time, and it's the most prominent provider. There's a large community of people that use AWS, and there's a lot of support for it, and there are many different services. So working with AWS, even though you're taking away all the infrastructure pieces, the irony is, even though that's abstracted away from you, it's still not really easy. you have to, whether you're working with the AWS console, which is the web portal, or the command line interface, or the software development kit, there's a lot of configuration details that you have to think about. There's a lot of jargon that you have to learn about. And then also, something that you might think of as one task, like a discrete task, is actually composed of many smaller tasks under the hood. So before I get into AWS a little further, I want to talk a little bit about like an example scenario. So say you work at a company and you have someone who's not in the development team, like a sales manager, who is wants some data from the database. And you could query the database whenever they ask you to and send it to them, which is kind of cumbersome. Or maybe you could write a script that would query the database and format it in whatever way they need it, and then send it to them whenever they need it. Or you could write some application that kind of does that, plus provides some sort of portal for them to view it in. And you could create that application. I mean, you could have a physical server that does it, whatever way. But this is kind of a situation that would be optimal for something like FOS and BOS, because you have two different parts. The AWS Lambda in this case could handle the retrieval of information and the formatting, processing of that information. And then AWS API Gateway could provide an endpoint that the sales manager could hit to access that information. First I'm going to show you what it would be like using the AWS Software Development Kit to do that. So this would be how you deploy an AWS Lambda integrated with an API Gateway endpoint so that the sales manager can visit that and then see the information they need to see. So there's a few symbols. Some of you are probably really familiar with AWS. Some of you are not. AWS Lambda is this one. Then there's API Gateway. DynamoDB is the key value and document store for the NoSQL storage for AWS. There's an edge location, which is like a data center on the CloudFront network. And then there's IAM, which is Identity and Access Management, which just really handles permissions. So throughout the next few slides, I'm going to be talking about two service objects. There's the Lambda service object, and then the API service object. I'll be using those to talk about a variety of operations that will need to happen for this whole process to occur. So the first operation is create function, and this just creates the Lambda. Like you give it some parameters, like the name of the Lambda, like a zip file that contains the code that you want to deploy, and then also each Lambda has to assume an IAM role, like it has to, and that just controls the permissions that it has. So then you create the API, create REST API, and at this point you have the API and a root path resource on the API, which is represented by the root / in the light blue background. So you have the root / and then down at the bottom, www.example.com / that's the root /. That's just the root part of the path. If you want to add path parameters, you need to, especially if you want to add path parameters and have it really accept any path parameters, you also need to add a greedy path, which is represented by the proxy plus in curly braces, which will match any portion of the path after the root /. So here in this example, it'd be 2018-11. And then at this point, you have to create that greedy path resource, and you have to first get the root path resource to pass it to the greedy path resource for it to then exist. And so now Lambda exists, the API Gateway exists, the root path and the greedy path exist, and there are a few things that you have to do for each of them. So the next 3 slides are operations that have to be performed for each of those. So you have to add permission for the Lambda to be able to invoke for the API to be able to invoke the Lambda. And then you have to add each HTTP method. And then you have to create an integration between the Lambda and the API. And an integration is just the API gateway will just pass along the request, maybe with some other processing, to another AWS service. And so the integration that we're going to use here is what's called AWS proxy or Lambda proxy. And what that does is it will provide the most details from the HTTP request within the Lambda. So then you have to repeat those last 3 methods for the greedy path. So you're adding permission for the resource to invoke the Lambda. Then you're adding the HTTP methods. And then you're creating the integration. And so after all that's done, all the resources, integrations, methods are kind of bundled up into one deployment resource. And then there's an endpoint that can be called. So that's a lot of steps. And if you needed to do this a lot, it would be kind of irritating. So developers have built frameworks to make that process a little simpler. And there are a variety of frameworks. I'm going to talk about 4. They run the gamut from, on the left-hand side, being really complex with a lot of functionality, but maybe geared more toward enterprise, something like serverless. And then on the right side, they're simpler, maybe lack some functionality, but they're optimized for some specific task. And so over the next few slides, I'm going to talk about each framework and then also show you an example, a GIF of what it would be like deploying a Lambda integrated with an endpoint using that framework. So for serverless, the pros are it supports a variety of providers, not just AWS, and runtimes, not just Node. And there's also a wide range of configuration and functionality. They include prefab Lambda code and Lambda templates. The cons are you have to configure a YAML file to deploy, and you have to know all the parameters that you need to work with. It will create a number of AWS resources behind the scenes for even a simple deployment, and based on my tests, it took about 2 minutes on average to deploy a Lambda integrated with an endpoint. So I'm going to show that. So here you'll see like a directory, like a project directory is created. And then the first command will create the setup code, including the YAML file. And then here's the YAML file. And I kind of cheated, like I just copied what the configuration is and pasted it in just so the GIF would move along a little quicker. And then here's the deploy, which will create a number of things behind the scenes. And then once it's done doing that, it'll create a number of resources. So I don't think we have to watch the whole thing, but and then there's Claudia. Claudia is still has a lot of configuration options, and it's geared toward deploying APIs. It's simpler than serverless framework, and there are optimized modules for doing things like the bot builder. There's a Claudia API builder, which leads to one of the cons. So to use the API builder, which you need to use in order to deploy an API, you have to separately create a package JSON and install that package. And then also Claudia supports only Node.js and AWS services. And it took about 1 minute and 15 seconds to deploy. So it's about almost twice as fast as serverless. And here's an example of Claudia. So again, you're creating a project directory. And here's the creation of the package JSON, and then installing that API builder package. And then here's the Claudia create, which will create the Lambda integrated with the API. So again, a lot of things going on behind the scenes, resources being created. And so then you have Shep. Shep's pretty simple. It's geared toward deploying APIs connected to Lambdas. It has prompts instead of configuration files. That's a little friendlier to decide configuration. You can deploy multiple Lambdas at one time. And it can upload the difference between your local Lambda and what you have in AWS when you're redeploying, which leads to one of the cons. Because of the way that it bundles with Webpack, there's a lot of extra stuff that's on your Lambda code in the cloud. So your local Lambda might be like 20 lines of code. And on AWS, it's over 300 lines of code. And so if you then have to go into the console to edit it, it's kind of annoying. Shep also permits few configuration options and supports only Node.js, AWS Lambda, and API Gateway. And it took about the same amount of time as serverless. It took about 2 minutes to deploy. So here's Shep. You, again, create like a project directory using the shep new command. And then it goes through a number of prompts. It creates some resources, installs the dependencies, which takes quite a while. And so now, here's BAM. This is the framework that I worked on. The goal for BAM was for it to be pretty simple, was for a developer to be able to get Lambda and connected to a gateway up really quickly, and for that whole process to be easy. So it doesn't require a project directory or configuration file. You can deploy just a file. You can have a directory if you want. It can do one or the other. You can persist data between Lambda invocations using DynamoDB, and I'll talk a little bit more about that later when I get more into BAM. It includes helpful Lambda templates, which again I'll talk about later, and it took approximately 20 seconds on average for the deployment. So it's a lot quicker. The cons are the trade-offs. There's fewer configuration options, so it is simpler, and it just supports Node.js runtime, AWS Lambda, API Gateway, and DynamoDB. So here's the deployment with BAM. You just type BAM deploy my Lambda. You have a Lambda called mylambda.js in that directory, and then it creates the Lambda, and then it creates the endpoint, and that's it. So it's a lot quicker, again, a lot simpler, but if the goal is to deploy just an API or a Lambda connected to an API, it makes it easy. So before I get into the design decisions about BAM, I'm going to go the next step within the AWS journey and talk about what happens when a user visits the endpoint. So here's the sales manager who wants data for November 2018. And so they visit this endpoint that you've given them in their browser, and that will route their request through an edge location. So this BAM uses an edge-optimized endpoint, which is, for most cases, probably the best choice. There are a variety of different types of API gateways. Edge-optimized just means that it's going to route the request through the CloudFront network, so you can view that page or make that request from anywhere in the world, and it's a little bit faster. So Sales Manager makes the request to the edge-optimized endpoint. And quickly, a little note about security. So edge-optimized gateway endpoints are public. If you are deploying something that you want to be public, then that's great. If you're not, if you have some sensitive data that you're working with, then you probably want to take some measures to secure the endpoint. And there are a lot of things that you can do to secure it. BAM's going to assume that you're going to handle that. BAM is not going to tell you how to do that. It's going to let you take those measures yourself. So then it's routed from the edge location through CloudFront to the API gateway, which will then check with IAM to make sure that it has permission to invoke the Lambda. If it gets back a successful response, then it will invoke the Lambda, and the Lambda has access to the path parameters 2018.11. And then at this point, the Lambda will do something. Like it will do its job. And here, the Lambda's job is to make a query to a database to get the total sales for November 2018. So we'll get that data. And then at this point, if you need to, you can persist any part of that operation to DynamoDB. It could be that you're caching the result of that request, or maybe you just want to persist some metadata like timestamps about the request. And then the Lambda will return the result to the API gateway, and it has to be formatted as a JSON object with certain parameters so that the API gateway can transform it into an HTTP response, and then back to the edge location, and then to the sales manager who can view it in their browser. So now that I've talked a lot about AWS, I'll talk a little bit more about BAM and about the design of BAM. So as I mentioned, in working with AWS and working with some of the frameworks, it was remarkably cumbersome. So I wanted to design something that was really simple. So functionality balanced with ease of use was the goal. And so here are some of the commands, or here are the commands for BAM. There's the deployment command that I talked about. Redeploy will allow you to update an existing Lambda and/or endpoint. Create will create a local file based on a template. List will log Lambdas and their associated endpoints along with DynamoDB tables. Get will pull down Lambda code from the cloud. DB table will create a DynamoDB table. Delete will delete resources, and config will update the default settings. So all the commands have opinionated defaults, but it was important that they are able to be customized using flags. Deploy and redeploy both have a role option that allows an IAM role to be specified that Lambda will assume. There are also options to specify which HTTP methods will be added or removed to the gateway. And there are a number of options, and if you're interested, they're all in the documentation. So I assume that you'll probably use not just BAM when you're working with AWS services. You'll probably use also maybe the console, maybe the CLI, maybe another framework. BAM is meant to be compatible with resources that have been created using a variety of methods. So you can pull down code, modify it, and then redeploy it. It'll mostly treat AWS as a source of truth, but in certain cases, if something will not allow it to work, then it will gracefully handle that. Like for instance, as I mentioned, Lambda must assume an IAM role, and BAM will create a default role that all Lambdas can assume. And if for some reason you accidentally or on purpose delete that role in the console, it will always check and recreate it before deploying. So again, in working with other frameworks and working with AWS, it seemed like there are a lot of steps of configuration. And if you're not well-versed in the nuances of AWS services and you just want to deploy some resources, it'd kind of be nice to do that without having to configure it yourself. So there's no configuration needed with BAM at all. If you just write a valid Lambda file and then BAM deploy the name of that file, it'll be deployed. BAM will make a call to the Amazon Security Token Service to retrieve your account number. And then because it uses the AWS SDK, the software development kit, it doesn't have to touch your access key or secret access key. The SDK is just going to do that behind the scenes. So I assume that you'll probably be using dependencies in your Lambda code. And again, I didn't want you to have to write a package.json for those if you don't want to. So BAM will just parse those from the parse the Lambda code and determine which are npm packages and which are native node modules. And we'll install the npm packages and leave the native node modules alone because they're accessible from within the Lambda as is. So to do a deeper dive on all the things that need to happen before you deploy a Lambda. So say the developer is writing the sales report JavaScript file. You'll first need to check to make sure that it's a correct Lambda file that's in the right format. You will need to make sure that the name is unique on AWS. AWS will only allow one name or a Lambda or won't allow Lambdas to have the same name per account per region. And then there's the .bam hidden staging directory that's used to, or .bam hidden directory that's a staging directory that's used to install dependencies and zip up the Lambda code to send it on to AWS. And then there are a variety of JSON files that are in there also that keep track of the resources so that after you deploy, you can use the list command to show all the resources you've deployed. And so to make sure that you are able to write code in the correct format, there are templates. There's the create command that will create some handy templates, each of which has access to the HTTP method from the request, the path parameters, query string parameters, and will also return a response that can be formatted into a valid HTTP response. So additionally, there's the HTML method, which will create JavaScript, CSS, and HTML files that are accessible from within the Lambda. If you guys have a chance at some point to check out the website for the project, which is bam-lambda.com, I used this to deploy the website. So you can kind of check it out. Kind of cool. And then also there's the invoker template that will allow you to invoke an existing Lambda from within your code, and then the DB template that allows you to work with DynamoDB instances. And these can be created with or without instructional comments. And then also, if you're really familiar with Lambda and don't need them, you don't have to use them. So one challenge in working with FOS in general, and specifically AWS Lambda, is that because they're spun up on an as-needed basis, and you don't know where they're going to be spun up, you can't count on any state being persisted between invocations. So as I mentioned before, an option is DynamoDB. BAM allows you to create a DynamoDB table and work with it so that you can persist any data like metadata or whatever else you'd like to persist. So because each of those commands, like the deploy command, they encapsulate a variety of SDK operations in one command, there were some issues that I consistently ran into, specifically regarding latency and rate limits. So a latency issue might be where an operation would need an AWS service to be in a particular state for the operation to be successful. Like where I showed Lambda was created, then an API gateway was created, and then you're going to add permission for the Lambda to be invoked by the API. So whenever those resources are created, AWS will optimistically issue an AWS request object to signify that they're created. So they're created, but it hasn't propagated all across AWS's system, so that when you're trying to add permission for the API from the Lambda, the API doesn't exist yet for all intents and purposes for the Lambda. So that's one issue. Another issue is that there are rate limits. AWS throttles most SDK operations And so those are some things that needed to be worked with. So, and of course, like, I'm not in charge of AWS's architecture, so it's not like a traditional system design problem. I had to work around those issues and find some ways to work with it. So with latency and rate limit, they're both kind of like a question of timing. With latency, we would it would consistently get the invalid parameter value exception, and then with rate limits, it was the too many requests exception. So I needed something that would just retry, but only in the case of those particular errors. So I created a function called BamBam, named, of course, if you are unsuccessful at bamming, you bam again. And what it does is will gracefully retry an SDK operation until AWS is in a state to handle that operation. So here's an example of that. So say you're attempting to delete an API. If you issue the command and it works, then great, no big deal. But if it doesn't work and a too many requests exception is thrown, which would just mean that you're being throttled, BamBam will wait 15 seconds in this case and try the operation again and continue to try it until it's ultimately successful and there's a happy path. So it's important, of course, that it only be retried for a particular error, because otherwise something else is going on and it's better to just throw the error and stop. Otherwise, BamBam is just going to keep going in this loop forever. So that's it for BAM. And of course, though, there's always work to be done. So here are a few things that I'd like to add in the near future. The first of which being cross-origin resource sharing, so that your endpoint can be called from any other application. You can do this now in the AWS console really easily. You can just check a box. But it'd be nice to do it from within the framework. Also, adding the ability to work with S3 buckets for other assets like images. And then additional language support. So I love Node.js, but there are other runtimes that Lambda supports, such as Java, Python. In November, they added support for Ruby and for custom runtimes like Rust. So it'd be cool to add support for those runtimes as well. So that's it. This is me. That's my contact information. There's the website that I mentioned. If you want to contact me, feel free. Yeah. Thanks, everybody. Thank you.